So we are dealing with this second problem of the paper 1 of JEE Advanced paper 2025. In an scattering experiment, a particle of mass 2m collides with another particle of mass m which is initially at rest. Assuming the collision to be perfectly elastic, the maximum angular deviation of the heavier particle as shown in the figure will be in radians. So we need to give the answer in radians. So let's get started with the problem. So a situation like this is given in the problem, and over here we are just drawing a x axis and a y axis. तब अपने ऐसा कह रहे हैं कि एक पार्टिकल है u स्पीड से मूव कर रहा है, दूसरा पार्टिकल रेस्ट पे है, एंड देन आफ्टर कोलिजन दे आर मूविंग इन अ वे लाइक दिस. This is the angle theta which is given in the problem, for which we have to calculate the maximum value of deviation, and we have another theta naught. So theta naught is not given in the problem. I will introduce theta naught. So in case if you want to know the reference to this problem, this is problem number 1.175 of IE Irodov, and it completely matches with the problem. And I've already uploaded in my channel the solution of IE Irodov of 1.175. But then also let's get started with the problem in the fresh way. So we can say that the P initial in the x direction is equal to P final in the x direction. So over here, if I call this as P, which is obviously product of m1 into u, then we can write that in the x direction this is p1 cos theta and this is p2 cos theta, where p1 is m1 v1 and m2 v2. So we are writing it as p1 cos theta plus p2 cos theta naught, and then we can definitely write it as p minus p1 cos theta is equal to p2 cos theta naught, and p minus p1 cos theta squared is equal to p2 square cos square theta naught. So this is equation number 1 that we have. And why I have done this, we'll come to know later in the problem why I am doing this kind of a calculation initially. So P initial in the y direction must match with the P final in the y direction. So over here we can say that along y the velocity is 0, momentum is 0, and then we have m1 v1 sine theta minus m2 v2 sine theta naught. So the component of velocity v cos theta will be in this side and v sine theta on the other side. So along y axis, upward positive, downward negative. So we are writing upward as positive and the downward as negative. Or in terms of momentum, we can definitely write it as p1 square sine square theta is equal to p2 square sine square theta naught, and this is the second equation that we have. So over here, from both these aspects, that p minus p1 cos theta square equal to p2 square cos square theta and p2 square sine square theta. So over here, if I add the expressions, then definitely you can say sine square theta plus cos square theta is equal to 1. So therefore, from both equation 1 and 2, we can write it as p1 square plus p square minus 2p p1 cos theta is equal to p2 square. So we have opened this bracket, that is p square plus p1 square cos square theta minus 2p p1 cos theta plus p1 square sine square theta to obtain the left hand side. And then on the right hand side we have obtained sine square theta plus cos square theta 1, so we have obtained p2 square. So this we are referring as equation A over here. Now let us write the kinetic energy expression, because in the problem it is stated that it is elastic collision. So kinetic energy initial must be equal to kinetic energy final. So kinetic energy initial must be matching with the kinetic energy final, and we will definitely maintain this order where we are writing energy or kinetic energy in terms of momentum. So we will write p square by 2 m1 is equal to p1 square by 2 m1 plus p2 square by 2 m2, and this we are referring as the third equation, maybe fourth if you are writing 1 2 3 or fourth. So over here, if we substitute the value of this expression, so we write it as p square by 2 m1, and then we are writing it as p1 square by 2 m1 plus p1 square p2 square by 2 m1. So over here I have introduced this quantity like this, plus p square by 2 m2 minus twice of p1 cos theta by 2 m2. So technically we have written this equation by substituting p2 square from here. So if we substitute p2 square as p1 square plus p square minus 2p p1 cos theta, and then we have 2m2 in the base, so we get something like this. So this entire term is because of the replacement of p2 square from equation A, which we obtained earlier. So now we can rearrange the terms, and on rearranging the terms we can write it as half of 1 by m1 plus 1 by m2 p1 square minus 2p cos theta upon 2 m2 p1 plus p square by 2 m2 minus p square by 2 m1 is equal to 0. So it is taking this form where we can refer this one as a parameter A, this one as a parameter B, and this one is a parameter C, because we are having a quadratic equation in p1 square. So since we are having a quadratic equation in p1 square, we can say A, B and C, and then we are saying that for this to have real roots, so discriminant must be greater than equal to 0. So b square minus 4ac will be greater than 0. So p square cos square theta by m2 square minus, so b square minus 4ac, so a being this a, and then we have c, 2 again taken common, so we can write it as p square by 2 1 by m2 minus 1 by m1 must be greater than equal to 0. So from here we can obtain this expression for cos square theta, that cos square theta by m2 square is equal to m1 square minus m2 square by m1 square m2 square, and from here we obtain the expression for cos square theta as m1 square minus m2 square by m1 square. Or we can write the answer the way it is given in Irodov, that sin theta maximum. So for maximum we have equated the cos theta part to be, equalities obtained. So we obtained sin theta maximum corresponding to this being equal to m2 by m1. So it will come to this form, m2 by m1. Now if we go back to the problem to see m2 and m1, so we can say that m2 is equal to m, which was the particle initially at rest, and m1 is equal to 2m. So sin theta maximum, so the maximum angular deviation theta maximum is equal to m2 by m1 or m by 2m. So we have half, and in radian we can say that this value is 30 degree, or in radian pi by 6. So theta maximum is equal to pi by 6, that is, it is matching with option D. So this is the second problem of paper 1 of JEE Advanced 2025, and coincidentally it matches with 1.175 of Irodov.